Hello everyone, this is Professor DePaulo. Welcome you back to Psych 220 Behavioral Statistics. And I'm going to do some walkthrough of problems. And for this video, I'm going to walk through the correlated t-test. Correlated groups t-test, which most commonly presents itself as a repeated measures design with two groups. And traditionally, this is before versus after. And you have these are two groups, two measurements, but generally the same person in each of the before and after conditions. So it's basically one person getting a measure before and one person, the same person, getting the measure after. All right, it can be matched pairs, but that's pretty rare. The vast majority of time, it's repeated measures with the same individual getting measured twice. And that creates these two groups. And these two groups are correlated. That's why it's called the correlated groups, correlated t-test. Now let's look at this problem here. A researcher is studying if Botox reduces migraine headaches. A group of 9 migraine sufferers participated in the study. The number of migraine headaches in a month before starting Botox and then again after receiving treatment was recorded. The data are as follows. So you have a before and you have an after. So to set up this problem, we need to have a difference score. So what I'm going to do is I'm going to write down here before and after. So let me just recopy that, because this will allow me to have more room than trying to squeeze it in that first column. You want to line up the numbers the best you can, and of course 10, 2, 10, 6, 5, 8, 7, 9, 12, 8. The main issue with this kind of thing is writing on the damn tablet, which is a bit sloppy. So let me write after. This always takes a bit of adjustment. So you want to line it up. 10 is 7, 6 is 5, 5 is 7, 8 is 3, and these are weekly migraine or monthly migraine headaches. 7 is 7, 9 is 5, 12 is 10, 8 is 5, 5 is 6. If you ever had migraine headaches, and they can get very severe, Botox is an effective treatment for the majority of people with migraine that hasn't progressed to medication overuse headache, which is basically you're taking so much medicine, so many painkillers for your migraines, that the headaches are getting worse because of the medication. But Botox works before you get to that medication overuse headache stage. So before and after, and I'm going to create a difference score, a D column. This is for difference score. Now I expect after to be less than before because I'm reducing. My prediction is reducing migraine headaches. So after should be less than before. So if I do before minus after, I expect positive values because after should be less than before. If Botox reduces migraine, which it should. So I'm doing before minus after, and I'm expecting a positive value. Positive value is going to be in compliance or in support of my hypothesis. Here I have a negative value. But most of these are positive values. Here's 0. So there are a couple people that are not benefiting from Botox for migraine. So that's my D column. Now I need to find the mean of D. So the mean of D is going to be the sum of D. Actually, let me put mean of D somewhere else. Let's do sum of D here first. I would do this in my head, but I have the wonderful RStudio Online, RStudio Cloud here to do this for me. So if I do before minus after, I get my different scores. So let's check those. 3 minus 1. Let me zoom out for a minute. 3 minus 1 minus 3, 1 minus 2, 5, 0, 4, 2, 3, negative 1. So that's correct. And let's do the sum of that. $15. So let me go back and go to 100 for here. Move this down a bit for now. So that's 15. 4, 2, 7, 11, 13, 16, 15. Looks good. Now let's do d squared. 9, 1, 4, 25, 0. So I'm just squaring the d column, which gives me all positive values. And then I'm going to get a sum of d squared here for this. So this one I definitely need to check because I don't want to do it in my head. Although this could be easily done in my head here. 10, 14, 39, 55, 59, 68, 69. So I'm getting 69 in my head. Let's check it and make sure that's right. So let's do before minus after squared to get me the d values, and then let's do the sum of that. To check to see if my math is correct, and it is 69. So I was able to do that one correctly. So now we have to get the formula to work with to calculate. First we need mean of d, and that's simple enough. So mean of d is sum of d over number of pairs of scores. So n here is the number of pairs of scores, right? Which is 1, 2, 3, 4, 5, 6, 7, 8, 9. So sum of d is 15, and n is 9. That gives me 1 6/9, which is 1.67 repeating. That is my mean of d, right? So I need that. I also need so that's the top part. So if we go to the formula sheet, which I've posted on Brightspace, so I have sum of square of d. So t is mean of d over the standard deviation of d divided by square root of n. So t is the mean of d over the standard deviation of d divided by the square root of n. So I have the mean of d. I need the standard deviation of d. Standard deviation of d is calculated using the other formula that I have here for you. The sum of squares of d over n minus 1 square root. So to find the sum of squares of d, we're going to do this. Sum of d squared minus sum of d quantity squared over n. So sum of squares of d equals sum of d squared minus sum of d quantity squared over n, where n is the number of pairs. So sum of d squared, I have at 69. The sum of d is 15. Square that over n, which is 9. That gives me 69. So this is finding the sum of squares of the d column. That's all it is. 15 squared is 225 over 9. Whoops. How did I do that? I hit a wrong button. That gives me 69 minus this value, 225 over 9, which I will check with this. That gives me 25. And 69 minus 25 gives me 44. That is my sum of squares of D. To find the standard deviation of D, I gotta take the sum of squares, divide by n minus 1, which is 9 minus 1 is 8, and take the square root of that. So it's 44 over 8 square root. So this is going to be 5.5, square root of 5.5. Let's see what that is. It's going to give me 2.35 rounded. 2.35 rounded. That's my standard deviation of D, right? So I had that here as, let's write the formulas down here. Sum of squares of D, I have that down below that, so I don't have to write that again. Let's do S of D is sum of squares of D divided by n minus 1. That's the variance, and then take the square root of that to get the standard deviation. So that's what I'm doing right here. That gives me 2.35. So this gives me on top, the mean of D is 1.67. The standard deviation of D here, which we computed, is 2.35. But I need to divide by a square root of n to get the standard error, really, of D. That's what, so standard deviation of the different scores divided by the square root of n is the standard error of the different scores. So it's 2.35 over square root of 9, which we know is 3. This is 2.35 divided by 3. So let's do that calculation. So 1.67 divided by this 2.35 divided by 3. That gives me 2.13 as my answer. So this is 2.13 as my final t value. And like everything else I'm doing here, we're going to test it against R, the all-knowing R. And I'm going to test that as before, comma, after. And we want to do paired equals true. And alternative, well, we don't need that right now. Paired is true. And that gives me 2.13 on 8 degrees of freedom. And you can see the two-tailed value is not significant, but we're not going to be doing two-tailed. So this was just to check the calculation. We know that the degrees of freedom is equal to the number of pairs of scores minus 1. There's 9 pairs of scores, minus 1 is 8. So 9 minus 1 is 8. So that's my degrees of freedom. Now we need to know the critical value. So the critical value of t with 8 degrees of freedom. And we need to, actually we need to write the hypothesis so we know if I'm looking for one tail or two tail. So if we go back and we look at this problem, we're looking at Botox reducing migraine headaches. So this is directional because we're looking at reduction. We're not looking at change, we're looking at reduction. So directional, one tail. So I want one tail at alpha of 0.05 for the critical value. One tail alpha at 0.05. We're going to look at the chart. This is the formula sheet. Here's the T distribution. And we want one-tailed, so the top row is one-tailed. Alpha of 0.05, which is this middle column. One-tailed. And we have 8 degrees of freedom. That gives us 1.860 as a critical value. 1.860. Now, it's positive because we're hypothesizing a reduction. So we're expecting before minus after to give a positive value, because after should be lower than before. That's what we're expecting when we say reduction. Before minus after should be a positive value, right? So if we expect before minus after to give us a positive D value, then we expect the critical T to be positive. So positive 1.860. Compare this T value to our critical value, and if you want to do a little drawing, here's 0. Critical value somewhere here is 1.860. And your actual value is down here, 2.13. Since it's in the tail, it's more extreme than the critical value. We're going to reject the null. Now let's look at what our hypotheses are. We're rejecting the null. The null says, of course, Botox has no effect on migraine. The alternative, we're looking for reduction. We're specifying reduction. So Botox leads to a reduction in migraine headaches. And this is just one way of phrasing this, migraine headaches. So we're rejecting the null, and we support the alternative that Botox leads to a reduction of migraine headaches. And most of the data out there will show that to be the case. Even with a small sample, Botox, if you know anything about migraine and know anything about Botox works very, very well. I think it works better than nerve block, which is used also, and probably better than the blood pressure meds or the triptan drugs, like the similar to SSRI drugs. And also, Botox works better than some of the other off-label drugs that are used for migraine, and definitely better than the opiate drugs, because opiate drugs cause the rebound headaches. But even the NSAIDs, the non-steroid anti-inflammatory drugs, will cause a rebound headache in terms of migraine. So this data shows what we expect based on the literature and our knowledge of what Botox does. That Botox reduces monthly migraine headaches in this population. And that's pretty much it. So summarizing this again, you have before and after. If you expect a reduction, you expect before minus after to be positive. If you expect an increase, then you would expect before minus after to be negative. Okay, but since I expect a reduction, I expect a positive value. I calculate all my D values, the difference scores. I then sum them up, sum of D. I then square all my difference scores. I also sum up that column. I then find the mean of D, which is sum of D over the number of pairs of scores, which is 1.67. I then calculate the sum of squares of D by taking sum of D squared, 69, minus sum of D, 15, square that over 9, number of pairs of scores. That gives me 44. I then take that sum of squares divided by n minus 1 to get the variance. So 44 over 8 gives me the variance, but I have to take the square root of that to get the standard deviation. So square root of 44 over 8 eventually gives me 2.35. I then plug all those values into the formula. Mean of D we have here. The standard deviation of D is right here, 2.35. And then the square root of n is the square root of 9, number of pairs of scores. I then simplify that fraction. I get 2.13. I know my degrees of freedom is number of pairs of score minus 1, which is 8. I then look up the critical t in the table. I compare my obtained t to the critical t, and if my obtained t is more extreme than the critical t, I reject the null. 2.13 is more extreme than 1.860, therefore I reject the null, support the alternative that Botox leads to a reduction in migraine headaches. And that's it. So hopefully that clears up or helps you with the correlated groups t-test, and there'll be more videos on each of the problems moving forward. Bye for now. See you on the next video.